Researchers at Monash University developed the dishbrain computer chip by incorporating around 800,000 human and mouse brain cells into its electrodes. The chip exhibited rudimentary sentience and quickly learned to play Pong through interactions between brain cells and electrical stimuli. The microelectrode array in dishbrain read brain cell activity and stimulated them with electrical signals, allowing the brain cells to control a Pong paddle's movement. A basic reward system was set up, where hitting the ball resulted in predictable stimulation, while missing led to unpredictable stimulation, enhancing the chip's learning. The research collaboration with Melbourne startup Cortical Labs secured a $407,000 grant from Australia's National Intelligence and Security Discovery Research Grants Program. Dishbrain's fusion of biological computing and artificial intelligence could potentially outperform traditional silicon-based hardware, with applications in fields like robotics, automation, brain-machine interfaces, and drug discovery. The technology could usher in a new generation of machine learning for autonomous vehicles, drones, and robots, enabling continuous learning, adaptability, and optimization of computing resources. Zenvo Automotive and MAIL are collaborating to create the world's most powerful V12 engine for a road-going car. The V12 engine, part of Zenvo's new Aurora hypercar, will have a displacement of 6.6 liters and feature quad turbocharging. It is expected to produce a peak power of 1,250 horsepower at 8,000 RPM, revving up to 9,800 RPM. The engine will be the centerpiece of a hybrid drive system, with a total combined power output of over 1,800 horsepower. MAIL's jet ignition technology will improve combustion efficiency and fuel economy, while meeting Euro 7 emissions regulations. The hybrid setup will also include a 600 horsepower electric drive, providing all-wheel drive and enhanced environmental credentials. The Aurora hypercar will feature a modular chassis with a carbon monocoque and carbon subframes. The hybrid powertrain's layout suggests all-electric commuting potential alongside high-performance capabilities. Zenvo plans to unveil the Aurora at the Quail during Monterey Car Week 2023, offering both track-focused and GT variants. The hypercar's modular engine design hints at future Zenvo models featuring V6 and V8 derivatives. Engineers at RMIT have enhanced the energy density of proton flow batteries, making them competitive with commercial lithium-ion batteries in terms of capacity. The improved proton battery boasts a specific energy density of 245 Wh/kg, challenging lithium-ion batteries used in vehicles like Tesla's Model 3. The proton battery technology avoids using lithium, addressing concerns about a potential lithium supply shortage and geopolitical dependencies. The battery functions like a reversible fuel cell, storing positively charged hydrogen ions in a solid, porous carbon electrode, soaked in a dilute acid. Innovations include vacuum drying of carbon powder, mild heating during operation, and a thinner gas diffusion layer, leading to significantly improved energy density. The technology offers a safer, stable, and recyclable way to transport hydrogen, with potential for fast charging. Proton batteries use abundant and inexpensive materials, contributing to cost-effectiveness and environmental sustainability. The battery demonstrates higher round-trip energy efficiency compared to conventional hydrogen systems, with over 75% targeted efficiency. The research team plans to collaborate with Elder Corporation for further development and scalability of proton battery technology. Scientists at the University of Colorado Anschutz Medical Campus, UC Anschutz, have identified a mechanism behind age-related cognitive decline. The research focuses on a brain protein called CAMKI, crucial for memory and learning. Altering this protein in young mice led to cognitive decline similar to that of older animals. The decline in cognitive function is linked to a process called S-nitrosylation, which affects brain proteins including CAMKI. The study suggests that maintaining nitrosylation function through therapeutics could potentially halt age-related cognitive decline without adverse effects. The treatment might work for age-related cognitive decline, but not for conditions like Alzheimer's and dementia. The researchers believe this protein can be targeted and are considering pharmacological interventions as the next step in their research. Engineers at the University of Connecticut have developed a strong and lightweight material. By combining DNA and glass, DNA self-assembles into lattice shapes, which are then coated in a glassy material. The resulting glass-coated DNA nanolattice material exhibits compressive strength of up to 5 gigapascals, 4 times stronger than steel, but with 1/5 of the density. The material's strength comes from the combined support of both DNA and glass components. The researchers aim to further improve the material by experimenting with different DNA structures and alternative materials like carbide ceramics. This new approach offers potential for designing 3D framework nanomaterials with enhanced mechanical properties. The CudaJet is an underwater jetpack designed as a backpack-style propulsion system. Developed by Archie O'Brien, it was originally conceived as the Cuda prototype 5 years ago. The final commercial version, CudaJet, features dual jet drives attached to a neoprene harness worn on the torso. A handheld remote controls speed and monitors the lithium battery charge, providing up to 40 minutes of runtime on a 75-minute charge. The jetpack can operate down to a maximum depth of 40 meters, 131 feet, and offers 40 kilograms, 88 pounds, of thrust, reaching speeds of up to 3 meters, 10 feet per second. The complete CudaJet package weighs about 15 kilograms, 33 pounds, on land, and starts at a price of £14,000. Approximately US $18,021. Availability details are pending, and the jetpack has been showcased in action through a video demonstration. Scientists have identified a new type of immune cell that develops in individuals who successfully combat cancer, which they refer to as superior T cells. These immune cells, discovered through a study at Cardiff University, target multiple cancer-associated proteins simultaneously, distinguishing them from regular killer T cells that typically target one protein at a time. The research focused on tumor-infiltrating lymphocyte (TIL) therapy, following patients who cleared cancer after treatment and observing their immune responses. Superior T cells show strong and sustained responses even a year after cancer remission, indicating their potential significance in preventing tumor recurrence. These multi-pronged T cells were absent in patients whose cancer progressed, suggesting a link between their presence and successful cancer clearance. The discovery could lead to more effective cancer therapies, and researchers aim to investigate their potential for genetically engineered treatments in the future. Further research is required to establish a definitive link between superior T cells and cancer clearance, and to explore their therapeutic applications. Researchers at the University of Copenhagen have transplanted healthy human glial progenitor cells, HGPCS, into mice brains, demonstrating their ability to replace both unhealthy and aged glial cells. Glial cells are support cells for neurons and play critical roles in brain function, including astrocytes for support and protection, and oligodendrocytes for myelin production. Dysfunctional glial cells are associated with neurodegenerative and neuropsychiatric conditions, including Huntington's disease, ALS, multiple sclerosis, Parkinson's disease, Alzheimer's disease, autism spectrum disorder, ASD, bipolar disorder, and schizophrenia. In the study, healthy HGPCS replaced diseased glial cells in a mouse model of Huntington's disease, suggesting potential therapeutic applications for various diseases. The researchers propose clinical trials to test the effectiveness of HGPC transplantation in Huntington's disease, primary progressive multiple sclerosis (PPMS), and Pelizaeus-Merzbacher disease (PMD). The transplantation of healthy HGPCS could restore normal function in degenerative diseases, and human clinical trials are expected to commence within the next 2 years. The University of Cambridge, in collaboration with private industry, has developed a 3D printed concrete head wall structure for civil engineering applications. A robotic 3D printer arm was used to construct the head wall on site, using quick-setting concrete that hardened in an hour. Lighter scans were performed during printing to create a digital virtual twin of the structure for comparison. Wireless sensors embedded in the concrete transmit data on temperature, strain, pressure, humidity, electrical resistivity, and electrochemical potential. The project aims to assess the stability and feasibility of 3D printed concrete structures and their sensors for practical use in infrastructure projects. The team also aims to explore incorporating self-healing concrete technology into such structures in the future.